Assalamualaikum warahmatullahi wabarakatuh. Praise and gratitude to the Almighty God who has given us health and opportunity, which despite the coronavirus outbreak, we can still attend the seminar activities in online. Thank you very much for the opportunity given to me. My name is Yakob Purtikwatil from STT Mandala Bandung. Will represent the other team to present our journal paper entitled Electrical Energy Alternative of Magnetic Field Around Wire of Power Line. Background: electric energy crisis and consumer needs. Consumers are increasing while the availability of electricity is decreasing. The second, the existence of electric line with alternating electric current generated a large magnetic field around and along the power line that store electrical energy, but that has not been utilized. Great. There are public concerns about the danger of electromagnetic field radiation near the location of the power line. Purpose of this journal: first, utilize the magnetic field that is on the primary power line and making it a new source of electrical energy. Second, making an equipment that can take the magnetic field flux into an alternative magnetic power-based field with a voltage of 220 volts to provide electricity to the community near the location. And three, changing people's image about the danger of electromagnetic field radiation. Next, the basic theory. To understanding in the electromagnetic field technology on electric power line is based on Maxwell's law, Faraday's law, and several other laws. And this fixed one, you can see, say by Maxwell law, if electrical current flow in wire will generate magnetic field around the conductors, circular pattern, and the direction of motion of the magnetic flux is to follow the rules of the right-hand Fleming. And then, how to transmit the magnetic field energy? We can use toroid. Toroid is equipment that functions like transformer, magnetic field energy with an intensity of H can be collected by the toroid core. This coil is used as a secondary winding M2, which is connected to the load, and the electric power line wire is passed into the toroid cavity as a primary coil N1 which flow primary current I1. Then the physical size of this coil will determine how much magnetic energy can be taken. The greater the diameter and thickness of the toroid, the more magnetic energy will be taken. The large toroid size, especially the thickness and diameter, will be able to take in more magnetic flux from the magnetic field. Uh, in this equation 12, you can see that it means that to supply the load with power P2 asterisk with a voltage of 220 volts required primary current on power line that is equal to I1. In another sense, that the current of the power line will be able to generate power at the load by P2 asterisk at a voltage of 220 volts. And how to text the data, the experiment. To get the data, we conduct a simulation experiment in the laboratory in two ways as follow. One, experiment one. The system use like Fig and Fig 3A. You can see the system used an induction motor as a load of electric power line to obtain a large current flowing in the primary power line because a small electrical current cannot produce enough magnetic field energy to light the lamp normally. Experiment 2, we use Fig 3B like this using an alternating current fault regulator and a step-down transformer whose secondary side is short circuit drop and electric current meter to obtain a large and varied current on the toroid primary side and to find out how much current flow on the power line so that energy magnetic field can produce a normal voltage of 220 volts at the load on the toroid secondary side. The experiment result you can see in table 1A. The result of experiment with low current in the primary power line of 27 amperes. The state of 5 watts. The incandescent lamp lit but dimmed at 160 volts. And 10 watts incandescent lamp also lit, but dimly with a voltage 60 volts. This is caused by the weak intensity of the magnetic field generated by the electric power line current and Table 1B for medium current of 80 amperes on the power line as stable. The state of incandescent lamp 10 watts and 40 watts brightly lit at voltage greater than 220 volts, and for 60 watts incandescent lamp it light up but is dim with a voltage of 165 volts. This is caused by the weak intensity of the magnetic field generated by the electric power line current. But for 15-watt electronic lamp, 80 amperes power line current cannot detect the voltage value because it explodes and goes out. Experiment 2 to obtain a large and varied current on the toroid primary side, and to find out how much current must flow on the power line so that energy magnetic field can conduct a normal voltage of 220 volts at the load on the location secondary side. In table 2, it is shown the two tune on the 40-watt incandescent lamp require an electric current of 70 amperes. Then for 60-watt incandescent lamp requires an electric current of 105 amperes. And for 100-watt incandescent lamp, it requires an electric current of 175 amperes. Whereas for a 7-watt electronic lamp, it required an electric current of only 30 amperes. All I come on 220 volts. And next is figure 5 illustration 3 incandescent lamp, which is 40 watts, 60 watts, and 100 watt. Each lamp has a different slope graph. For a 100 watt lamp with a very sharp slope. This is due to shifting normal voltage value of 220 volts, requiring a large power line current reaching more than 175 amperes, whereas for lamps with 60 watts, approximately 107 amperes, and 40 watts require current of more than 70 amperes. The next conclusion. Words. The magnetic field energy along the electric power line can be utilized as alternative electrical energy using toroid. From the analysis through linear approach that in power lines with larger current up to hundreds of ampere can be obtained power up to several kilowatts at 220 volt. The greater the electric current that flow in the power line, the greater the magnetic field energy around the power line. Second, the more toroid is installed along the power line, the more new electric energy will be obtained. And this simulation circuit you can see in the fix three size toroid. T1 is toroid, big toroid. T2 needle toroid size, and three uh, small toroid. And finally, there's the paper that I can convey sensibly over 13 Wati Syafuddin Givira Viraran dan Milik Lestari Herawati WS Rahmat Hidayat Sekolah Tinggi Teknologi Mandala Bandung Universitas Kristen Mandala Maranatha Bandung Indonesia. Assalamualaikum warahmatullahi wabarakatuh. Peace to all of you. Thank you very much.